Question 6.10. Calculate the enthalpy change on freezing of 1 mole of water at 10 degrees Celsius to ice at minus 10 degrees Celsius. Enthalpy change of fusion is equal to 6.03 kilojoule per mole at 0 degrees Celsius. Then Cp means molar heat capacity at constant pressure of H2O when it is in liquid state is equal to 75.3 joule per mole per Kelvin, and molar heat capacity at constant pressure of H2O when it is solid state, means when H2O is in form of ice, then this is equal to 36.8 joule per mole per Kelvin. All these are given quantities. So let's find out enthalpy change during freezing. So let's understand what is freezing process. The enthalpy change on freezing this freezing is from 10 degrees Celsius to minus 10 degree Celsius. Okay, this process may be expressed as we cannot convert directly 10 degree Celsius water into minus 10 degree Celsius ice. It includes some steps. So first step, liquid initially it is in a liquid state at 10 degree Celsius. Okay, so water at 10 degree Celsius, it will change to liquid at 0 degree Celsius. Okay, so water will be cooled from 10 degree Celsius to liquid at 0 degree Celsius. Here enthalpy change, say delta H1. Okay, then this liquid will change to solid, that is in ice form, at 0 degree Celsius. Here enthalpy change is delta H2, and delta H2 is nothing but enthalpy of change of fusion, which is given in question. Okay, then finally this solid at 0 degree Celsius ice will change to temperature minus 10 degree Celsius, and here enthalpy change is delta H3. Okay, so total enthalpy change is nothing but delta H1 plus delta H2 plus delta H3. So let's calculate all those values. So first thing, it is calculation of delta H1. So this enthalpy change is related to when water is converted from 10 degree Celsius liquid to 0 degree Celsius liquid. And one important quantity is given, which is the 1 mole of water is converting from 10 degree Celsius to 0 degree Celsius. So mass mole of that is N. So here I am using the formula, that is N into Cp. Here water is in liquid state, so I am using molar heat capacity at constant pressure of, so Cp of H2O in liquid state into delta T. Delta T means change in temperature. Okay, so here number of moles of water is 1, and delta T, that is change in temperature, is final temperature is 0, and initial temperature is 10. So delta T is minus 10 degree Celsius. So let's put all these values. 1 into Cp of H2O in liquid state is 75.3 into change in temperature is minus 10. So after multiplication I will get minus 753 joule per mole. Okay. This is enthalpy change in first step. If I convert this into kilojoule, so divide this quantity by 1000. So after dividing this value with 1000, I will get 0.753. Now unit is kilojoule per mole. Correct? So this is calculation of delta H1. Second quantity is delta H2. Delta H2 is depend on enthalpy change of water from liquid at 0 degree Celsius to solid at 0 degree Celsius. So this is depend on enthalpy change of fusion, and it is given as number of moles of water into enthalpy change of fusion is negative quantity, because in this process heat is given out from the system. So 1 into minus 6.03 kilojoule per mole. So answer is minus 6.03 kilojoule per mole. Okay. Then third step. In third step, we are going to find out enthalpy change delta H3. Delta H3 is enthalpy change when ice at 0 degree Celsius is converted into ice at minus 10 degree Celsius. So here delta H3 is given by N, that is number of mole of water, into molar heat capacity of water in solid state, correct, into delta T. So N is 1 into heat capacity of H2 in solid state is 36.8. So it is 36.8 into change in temperature. Initial temperature, final temperature is minus 10 and initial temperature is 0. This is equal to minus 368 joule per mole. Let's convert this into kilojoule. Divide this quantity by 1000. Then delta H3 is equal to minus 0.368 kilojoule per mole. Okay. Delta H1 is equal to 0.753 kilojoule per mole. Delta H2 is equal to minus 6.03 kilojoule per mole, and delta H3 is equal to minus 0.368 kilojoule per mole. So let's add to find out total enthalpy change in system. Total enthalpy change delta H is equal to delta H1 plus delta H2 plus delta H3. We know that delta H1 is equal to minus 0.753. Then second quantity is minus 6.03 kilojoule per mole. And third quantity is 0.368 kilojoule per mole. Okay. After doing this addition, final answer would be minus 7.151 kilojoule per mole. Okay. So here I will get answer as enthalpy change is equal to minus 7.151 kilojoule per mole, which is required answer. Thank you.